two-dimensional vector example. This time we're going to work the electrical circuit example. It says an electrical circuit includes an inductor, a resistor connected in series. The combined impedance measured in ohms of the inductor and resistor can be expressed as a vector Z, where Z is equal to R in the I direction and XL in the J direction, where R denotes the impedance resistance of the resistor, XL denotes the impedance of the inductor. For this particular one, the reference angle theta is referred to as the phase angle if R is 100 ohms and XL is 30 ohms. Express Z in both vector notation and polar form. Okay, so what do we know? We know that the total impedance is the resistor impedance in the I direction and the inductor impedance in the XL direction. We know the values of each one of those. We also know that phi is called the phase angle. We'll measure that in degrees. That will come into play once we get into polar form, because what we're asked to do is express Z in vector and polar form. And so Z in vector form is very easy, because it's just, we basically have it expressed there, we just have to put in the numbers. That Z is, for the resistor we have 100 in the I direction, and for the inductor we have 30 in the J direction. And those are measured in ohms. So, part 1, easy points. Part 2, polar form. So that was vector. Polar form. Remember, that's where we need to get the magnitude of Z. And we need to get this angle, which they're going to call the phase angle. So remember, the magnitude of Z is going to be the square root of the x part, which is R, plus the y part, which is XL, and that phi is going to be the inverse of the y part, which is XL, over the x part, which is R. So this is a little bit more abstract to see, because we don't really think of, it's harder for us to think about these being in an XY plane. It's, you know, when we had forces up there, we think about those pretty easily in 2D space. This is a little bit difficult to conceptualize, but the point is it's still the same thing going on. So we can put in the values. This is 100 squared plus 30 squared. So Z is, once we get a calculator, the square root of 100 squared plus 30 squared. So it's 104.4 ohms. And for phi, it's going to be tan inverse of the 30 divided by the 100. So phi is going to be tan inverse 30 divided by 100. So I get that it's 16.7 degrees. So then I can rewrite Z in polar form is 104.4 ohms at 16.7 degrees. And that's example B.